All right, 8th graders, here with your cool down help for lesson 11, where we're writing an equation for a line. And we're trying to match the relationship to the graph. And the first thing that it asks us to do is to explain why the slope of line A is 2 over 6. Because if you count the slope triangle that they've made here, it's 1, 2, 3, 4, and some change, and 1 and some change. So it's not really a 2 to 6 relationship. We need to pick some better dots. So what I want to do is I want to pick some not so trashy points, because this point is just a bad choice because it doesn't fall on an intersection. So instead of going with that dot, I'm going to go down just a little bit further to where this dot lands on an actual intersection here, and I'm going to create that slope triangle. It's a little bit longer, a little bit taller, but it's proportional. It's similar to my original triangle that was in black there. It's just a little bit longer. And if I count over 1, 2, 3, 4, 5, 6, I got a length of 6. Actually, let me do it this way so it doesn't get in the way of what I want to do next. I'm going to draw it inverted here and kind of go on the opposite side of it, which is fine. I go over 6 and up 2. So I've got a rise of 2, a run of 6 on my slope triangle. And that is exactly matching my 2 over 6 slope that they say that it should be. So why is the slope of this line 2 over 6? Because I drew a slope triangle on the line with rise of 2 and a run of 6. So I can do that. I drew a slope triangle on the line with a rise of 2 and a slope and a run of 6, which is proving that it has that slope. All right, let's go to the next part. Label the horizontal and vertical sides of the triangle, the one that's there already, with expressions representing their length. Okay, so let's start with this one that I'm labeling here in gold. The length of that height in terms of an expression. So I'm going to do that. Oh, you guys, I've got visitors coming in and breaking in on the video. So Kanan and Eli have shown up. So if they make noises, just know that's who it is. So to get the height, there they are. They're making a special appearance. They're now YouTube All-Stars. You're not even on our team. Get out of here. I know I'm not. Am I famous, Mr. Kelly? You're famous now. Yes. Everyone's going to know, Kanan. Oh, yes. Oh, man. This is what happens when you have to stay after school, because you're bad kids. All right. So the height of this one, we know that the length from here to here is the representation of y. Your y value from the x-axis, that's how high you go up. You go over x and you go up y, right? So if this is y, and this section between here and here, you can count it out. 1, 2, 3, 4, 5, 6, 7. If this is 7, then that means that gold line that's left over can be expressed as the expression y minus 7. This is the video of interruptions, but I'm not stopping. I'm too far in, and I'm not stopping. I'm just going to have to call that person back. So let's go on to the next part. So we got y minus 7 for our height. And then let's look at the other part that we need to get. I'm going to do this one in purple. We need to give an expression for this, right, y'all? So that purple distance right there is our horizontal side. Now, typically with these types of problems, you're going to have a horizontal distance that is your x value that goes all the way from your y-axis over to where your point is. This would typically be x. You go over x, you go up y, right? That's how we got to that point there. But it's not all of x because we're taking off some of it. And I'll do that in red again. We don't want to include these that are here. And that's 1, 2, 3, 4, 5. So we take those 5 away, and that leaves us with the purple being simply x take away the 5. So we have an expression for the purple length that's x minus 5 and the gold length that's y minus 7. And that's the labeling that you had to do for number 2. So if you label those there, you're good to go. And then lastly, why is this equation true? Okay, why is y minus 7 over x minus 5 equal to 2 over 6? Okay, that's because if you look back at our triangle, our dark triangle that we started with, its rise is y minus 7. Its run is x minus 5. They're just setting up the slope of the triangle, and they're setting it equal to the slope of the good blue triangle that we did. So what we can write here for our explanation is we could say that the slope of all slope triangles on our line are equal. Something along those lines. You could even say something like the slope of the original triangle to the slope of our new slope triangle are equal. You could even set rise over run is equivalent for all similar triangles, is equal for all similar triangles on our line. Similar triangles on our line. But all they're doing is they're setting up the slope of the one that we wrote expressions for equal to the slope of what we know the line is, because it's rise 2 over 6, run 6. And so these should be equivalent to each other. And you can say something along those lines of the things that I wrote down at the bottom, or you could even say that this is the equation that says that they're proportional to each other. That would be another thing that you could say. You could talk about proportionality. Proportionality is equal among slopes on same line. And all this has to do that these are all on the same line as one another, and that's why we can do that. And that's your cool down help. See you guys. Thanks to special guest appearance by Eli Hayes and Kanan Sullivan. See you guys.